The ad.
Oh my god, it's an ad. Move around.
I'm moving. Ready?
No.
Okay.
Stay tuned for more later. But for now, it's... That's Ladyada.
With special guest MOSFET who's calling around here. Thank you, Sparky the Blue Smoke Monster, for the intro. Sparky the Blue Smoke Monster has returned and will be gracing us with his Sparky presence. Musical beats shortly. Tonight we're doing a lot of video and audio testing, and I've got some servo samples. I've actually got some new samples of this analog feedback servo. We actually stock these already in the shop. They're called analog feedback servos, and that's like the technical name for them. They're a lot like servos, except they have an extra wire. You know, they usually have a servo. It has 3 wires: power, ground, and signal. These have an extra wire, and that wire actually can be used to read the position of the servo horn. Like, so what's interesting about this is you can create like record and playback techniques, which can be interesting for robotics, where one of the hardest things about robotics is if you have like a 3-degree arm or something, it's like, well, how do you know which joints to move to make the motion you want? Like that reverse kinematics is hard. Well, with an analog feedback servo, you can record position of the servo. So I can show you the quick script I have. And I'm just testing, I have another supplier, and that supplier has sent me some samples. So we have this normal code called knob, and that will just twist. You twist the potentiometer, and it'll change the location of the servo based on that knob. It just reads the analog voltage. So if we go to the overhead, I'll hook up this demo. So here's the servo. Hold on, I don't need this right now. I got the servo. I got the potentiometer here hooked up to analog pin 0. I'll upload it to my feather. And this is the Metal Gear version. I got a Metal Gear version and a Plastic Gear version. Maybe we'll take apart the Metal Gear version because they're kind of cool looking. Okay, so this is done uploading. Let's see if this works. Did I get this? Oh, sorry. Pin. Okay. So now when I twist this knob, it rotates the servo. And then you want to go to scope cam. You can see the pulses. So servos take a signal pulse of about 1 to 2 milliseconds. It actually varies. It's not a hard and fast rule. I found that you want to try moving between like about 0.5 to 2.5, sometimes even 3 milliseconds. It just depends. But usually 50 or 60 hertz. So this is how you normally control it. You just send it different pulse widths, and it changes the orientation of the servo horn. But with a feedback servo, you can run a different sketch. So if we go back to my computer.
Tell me when you're going to be from one spot for a
I'm in, no, I'm going to be switching back and forth a
Okay.
little bit. So this version for analog feedback, it uses the EEPROM of the microcontroller, and it actually reads the analog value. After you press the record button, it records servo data to the EEPROM, and then when you hit the play button, it will play that EEPROM data back out. So you're using that feedback pin, that white wire, as a way of reading what the location is. And if you're not driving a servo, even Metal Gear servos, you can move them. And so as I move it, the analog voltage will shift. So let's hook up the oscilloscope. Grab another probe here. And just one moment, I will hook this up. Oh, hold on. Okay, so let's upload. Yes, this is the servo, and now I have it hooked up. So the blue probe is going to be watching the analog feedback pin. That's this white wire. And then I'm still going to be watching the signal out, which is the yellow probe. So there's a lot of probes going on here today. Yellow probe is over here reading the servo signal. I'm not using potentiometer at all. And then I have these two buttons wired up for record and playback. So let's upload this sketch. After this, when I go to the main view, yeah. Okay, so now let's go to overhead view. And I'll be doing this for a little bit. So what happens is that when you press the record button, you can hit record, and the red LED goes on, and you can twist this servo. And it's, you know, it's not easy to twist, but you can move it around, and then hit the record button again, and it's done. And then when you hit the play button, it will read back the motions that I made from the EEPROM, the stored data inside of the microcontroller, and play that back. So you can imagine if you have a robotic arm or like a leg for like a hexapod, you can, with your hands, move it the way you want and then play it back however you like. So I'm going to do a little bit of a more exciting recording. Oops. I don't think I recorded properly. Let me try again. There you go. And then you can play it as many times as you want. The only thing I didn't like about this feedback servo, it does work, but it doesn't have a mechanical stop. And so even though you only get about 180 degrees of, sorry, keep moving the wrong way, 180 degrees of motion, it rotates all the way around, which it makes it very confusing to use. But I thought maybe we would, I could take this apart and look at it. You want to do that?
Mm-hmm.
More time.
Yeah, can I do a question?
Yeah, go
What's
ahead.
a good scope that doesn't break the bank?
The wiggle scopes are pretty cheap. They're $400. I wouldn't get anything less than that. I think those, the pocket oscilloscopes are they're not good for a lot of signals. They're very low bandwidth, and I think the probes are annoying, and they don't have really good controls. Are actually the most important. You want to, one second, good controls.
Yeah.
Let me get my ultra tiny
Look at the microscope for a second.
screwdriver.
Look at this. It's a neopixel underneath the microscope. Ooh, ah.
Okay.
This is crazy.
Almost whacked my head. Okay, so I need my super teeny screwdriver because these are like this tiniest little screws. Oh, so I'm going to go to the overhead. I'm going to take this thing apart. Take a look at it. So it's got these little screws on the bottom. And this is my Weeha screwdriver kit. These are really great. I think I got these like college or something, but I still use them. Okay. I gotta because you know my head goes the opposite way. It's not mirrored. Okay, almost done. Last one. And I don't, you know, this is one of those, like, I like to have two sources for all of the components. So we currently get our servos, the analog feedback servos from Batan, but I like having another supplier. So this is the control board and the motor. So this is the motor. That's the action part. And then this is the control board, which is very small, but, you know, it doesn't need to be too big. So let's see what's going on here. So actually you can see that there is a potentiometer, right? So you can even see it says 502 right there. So it's a 50K potentiometer, right? 502, no, 5K potentiometer. It's carbon film, and then you can see that normally, so there's 3 wires that go. You can kind of see them. They're black against black, so it's a little tough. There's 3 wires that go from the potentiometer to the control board, and this white wire that we bring out goes to the wiper, the center pin. It's just an extra pin. Like, it's just an extra wire. It doesn't, there's no any extra circuitry to get the analog feedback. So people would used to do this. You'd used to take apart your servo and then clip onto the, or solder onto the center pin. But what's nice is that these just come pre-done for you. And then this is the control chip. It's kind of hard to read. Let me see if I can get in there. So you've got 2 tantalum capacitors. I don't know exactly what I can barely read this. As VTech something something. So this is going to be, I mean, you can see these thick traces. This is, you know, the motor driver chip probably. Very simple chip that just does the motor driving, H-bridge for this. And then under here, there is a little microcontroller, which, like, I can barely see. Is it Atmel? I don't know. We can look under the super small microscope. But this component has 2 small ceramic caps, and has a couple test points as well. So this is the microcontroller that actually reads the pulse signal and then converts that into motor control signals. You need a lot of pins, and then, you know, this is your motor. And then I can see if I can try to pull this out. You know what? It's kind of wedged. Oops. Well, that's that. Good times while it was in one piece. So this is a metal gear servo. So, you know, the first gear is always going to be plastic because it has to be, well, first off, it doesn't matter because there's not going to be a lot of torque on the first gear, so it's plastic. But then after that, all the other gears are metal. So you get a little bit more strength. Doesn't crack as easily, but you have to pay a little bit more because they're very nicely machined. These are very nicely machined little gears. They're beautiful. You can see this one is just press fit into this one. So it's not one piece. They actually make 2 different pieces, and then there's a little locating pin. And then they have a very clever little gearbox where this sort of just fits into here. And then, I don't know where this one will fit. Let me think where this one would fit. Oh, sorry, this one, these 2 over here. And as you get to, like, the stronger torque signals, actually, I don't know exactly how this goes. Yeah, as you get to the stronger signals, the pins get thicker and the rings get wider, so they can handle it. Kind of nice. So that's your metal gear servo. Now my hands are all greasy. And then we have a plastic gear version as well, which I'll test, but almost the same thing. Same control board, same everything. The only thing you're paying for with the metal gear, the only thing that makes it more expensive is these metal gears. On this one, they'd be molded plastic instead of machined metal. All right, so that's my servo sample. I will never get this back together. Doomed.
Give me a few minutes. I'm wondering because I gotta.
Yeah.
Is that my timer?
Yeah, I'm just checking this out. I thought maybe I would look at the. Should I take apart another servo? Maybe I'll take apart the big one while you. Okay, so I'll do that while you
Yeah,
do your next thing. All right, so now I've got this other servo. It's a bigger. I'll take apart this one too. Why not? We're just hanging out. This one actually, what's nice about this one, I won't take apart the gearbox maybe, but this one, you know, it's just going to be a lot stronger. It does have stops, so it's kind of nice. So, maybe this is the right. Not really. This one's the right size. Yeah. Okay. All right, so for this one, a little bit different. So you see actually a full H bridge here, which is kind of interesting. A little bit cheaper maybe for the amount of current you need for this way bigger motor. I mean, you can just compare the motor size. This is like huge in comparison. You can actually see there are 4 transistors or FETs. It says 8 B77-2 maybe. Another tantalum capacitor, a couple of small passives, transistor. You have some white blob here that's a little strain relief. And then if I remove this strain relief, I'll turn this over. So now you see there's another potentiometer. It's a little easier to see this one. Potentiometer here, and then that white wire is an extra wire. Normally there's just 3 wires. Kind of don't like that they use red for the center, but not the servo designer here. And then for the microcontroller, it says KC2462. I don't know, I could look it up. Probably some like ultra cheap 8051 microcontroller. I mean, like this is such a simple program that even if it saves you, 2 cents, it's worth it to, change it to a different microcontroller, because anything with a single analog digital input of any kind that can do pulse output, I mean, it's a dedicated controller. You don't even need to have timers on this microcontroller. You just need like 8 pins and analog digital input. And so interesting that they went with this chip, different chip than the other one. I wonder if I can see it now. This says...
Here's a question from the chat. Can you use the analog feedback to get the angular position of the horn?
That's exactly what it tells you. Yeah, that this potentiometer is hooked up to the horn directly. So you can read the output right from the... whoops. I think I already popped this open. Hold on.
I would suggest backing that camera out a bit because you look less.
Yeah.
Personally.
Okay, well,
that way people can see a little bit more.
I guess I'm going to just open this up. So this is the plastic gear. Oh, you know what's interesting? You can see there's a little ball bearing race there. Nice. But yes, the potentiometer goes through and measures the position here. So this is like super greasy, but you can see here. Another gearbox, not as compact, plastic. Don't know why there's like one, like poly Definitely like different colored plastic.
A little shout out from the chat. This is from Gamma Pison.
Yeah.
Just wanted to thank you guys for the amazing products and tips you guys and gals provide. It's really a big help to my cosplay and my prop shop.
Oh, yay. Okay, so I don't know how this fits back on. How does this like snap on? Oh, you know what? It's just the screws hold it in place. I see. So when I screw it back on, it'll hopefully. Maybe.
Pronunciation is prism. My apologies.
Prism.
Gamma prism.
Yeah, so this is the horn fits on. Whoa. Yeah, it doesn't like when I do that. And then this is the mechanical stop. I guess. Over here. Alright, well that's servos. Do we have another message from
No, that's it.
Professor?
We're going to try something a little bit different tonight, Ladyada.
Yeah?
Yeah, we have Sparky the Blue Smoke Monster is going to kick off some
Sweet jams?
a dance party.
Sweet jams!
All right, you ready?
Yeah, I'm just putting this thing together. Alright, hopefully
All
this
right.
survived.
All right, so that's it for you tonight.
Yeah, I'm just getting my hands dirty. Literally.
It's Sparky's time to dance.
Dance, Sparky.
You don't need capacitor. Saturday night, New York Sounds Club is Sparky's. That's right. Sparky the Blues Book Monster is going to kick it off with some music and some industrial manufacturing footage. Here we go.